Right, this is my second time trying this problem, concatenated words. Given an array of strings words without duplicates, return all concatenated words in a given list of words. A concatenated word is like this. It is shorter words in given. It's comprised of entirely of at least two shorter words. All right, so this is related to word break one problem. So we are simply for each character, we are looking if there's a break for some sort of word breaks that are forming the current word. And to do that, we will need a helper function, word break function, that will take the word we are looking for, which is, I'm going to call it word, and then we have word dictionary, or maybe maybe the set, but I guess this is fine. Okay, so we will call this, for now I'm going to call it like this. So here we also have to sort it because we want to start with the smaller elements and then build up to others. So I will sort words that sort based on key length, and then I want to, for every word in words, I simply want to call word break, and if we also need results like that. So if maybe should I have a set? No, I don't think so. So if the word break word, you pass word dictionary, should be here. So word set, maybe, or dictionary. Actually, I think I can use set. Set words, and here now after this I can basically have like my results that append my word, and later on I just return my results. So that's my algorithm there, and here I simply want to, so when do we stop? What do we need? So for word break we need to hold the dynamic array. So again, maybe just go over an example. So I have this. I will first create true, and these will be false. And then what happens is that I will have my I here, and then I will have my j here. And for that, first let's create a DP. DP will be array of false elements, and that will be n plus 1 elements in there, and the first one will be true, because if there's none, you can just break that, and the first one will be the first character. The empty list will be true, so the base case is actually that. And then you simply have, for every character in, or every I in range, the length of word, and then for every j in range, then we have I, because we want to go until I and see if the ith location is like, yeah, we will just perform this like if dp dpj, and if we call word break, the word will be now word from I, actually j to I, and the word set will be still the same. If this is the case, I will change the API to true, and then I'll just break. And at the end, we just return dp -1. So what happens here is that I'll go over from the word to words +1. Yes, from 1 to word +1, and I increase I check this. This is always false for the other words because they are not in. When I see cat, I see that cat is in our diction set. So when that's the case, we just change this to true like that, and then we increase j again. They're all false, and then j is 0. Now I increase I. Again, we have from j's position, which is actually the 0th position here, to cats is in the dictionary. So we turn this to true. Now we go in, and then we continue like this. And then when we are at G, we come here. When we are at this position, if that's the case, and there are no, this should be J. It should be J plus, it should start from 0, 1, 2, 3, 4. Now I'm at 4. I'm pointing to true, but now I'm at 4. I'm at 4, but I'm pointing to that. Okay. J is 4. It is pointing to here, but in an actual thing, it is pointing to that 0, 1, 2, 3, 4. So J is pointing to D. Right, so D and true. Okay, now it should work like that. Maybe run it and see if I missed anything. So we have recursion limits reached. See. 1 second. Right, so okay, I guess right, we have a problem here because of some things here. So I just go over this like that until I go like that and break. Actually, okay, just 1 second. Right, I'm back, and okay, I found out the problem. So here, instead of initializing everything, I have to add to the set here in word set that I need to add the word now at the end of this, because until that point I don't have that word, but after that I should be able to use it. This should be the, and okay, let's see, words. Yeah, maximum limits. Actually, we check it here. So we have set like that. We sort it. We have press. It's also working here. Oh, I don't have a base condition where if not words. So if not words, set return false, and then we should just stop. And okay, I guess no matter what, we're stuck at this. Maybe I find a solution. I'm gonna try it one more time. Just a second. Right, I just realized that I shouldn't have this here. Instead, I should just check if this is in the word set. If it is in the word set, then we turn the DPI to true, and doing that would lead us to infinite loop, infinite recursion. So this is the way to do it. So we are simply sorting based on the length, and then we are creating a set so that we over time build up our elements, or elements for the next words, the following words. And when we do that, we check if it is possible to break the word into subwords with the given elements in the word set. And we are doing it like this here, and at the end of this, if it is possible, we just return the last index of DP, because we are storing, if it is possible, for fnth like ith location to be if it can be built up from the word set. So all right, this was my answer from. I got some help from this Ayush. There are some templates about word break 1 used in concatenated words and word break 2. So it's pretty similar. This one is a bit different because it requires backtracking. But word break 1 is literally the same as using this same function here. And this is just running that for every word in our list. So right, so that was my answer, and the time complexity is of n to the power of 3, and then space complexity is of n, the maximum. Actually, it's the maximum. It's the m, where m like longest length words. Right, so that's it. I'm gonna submit it again. All right.